Hi student, today we will be going through how to draw a quadratic function graph. Okay, so to draw a quadratic function graph, there's one tip for you to identify whether your graph is open upwards or downwards based on your coefficients of your x squared value. Okay, so as you can see, if let's say your value is positive, coefficient, positive 1, positive 2, any positive number of your coefficient belong to your x squared, your graph going to open upward. Okay, present a U shape. And if let's say your coefficient of the x squared value is negative, negative 1, negative 5, negative 10. Okay, as long as it is a negative value, your graph going to open downward. Okay, these two graphs, we call it a parabola graph. Parabola graph. Okay, it will present a smooth curve regardless it open upwards or downward. And another point you have to know is a parabola, there is minimum and maximum point. Okay, when your graph is open upward, when your coefficient is positive value, you will have a minimum point here. Okay, and when your graph is open downward, so when your coefficients of your x squared is negative value, you will have a maximum point. Okay, we will look at example under questions 11.3. Question 3, y equal to 1 minus x squared. Okay, y equal to 1 minus x squared. Since this question never provide you with a specific range of the x value, what you're going to do now is you try to identify your y value when your x is, you can begin from negative 4. Usually I begin from negative 4, negative 3, negative 2, negative 1, 0, and see whether we can match with the y value or not. Okay, and as for your y, okay, we're going to calculate the y value now. So when your x value is negative 4, you substitute your x value into the quadratic equation. Okay, you will have negative 4, right? Your x value equal to negative 4. Put it into your equation. You will get y equal to 1 minus 16, which is negative 15. Okay. When your x value is negative 3, you are going to have 1 minus 9, which is negative 8. Okay, so from here we see patterns of your y value. Negative 15, negative 8, negative 3, 0, and this will be your minimum or maximum point. And from here, we know that the graph going to look like this, right? Means that you will have a maximum point of 0, 1. This is your maximum point, 0, 1. Okay? So once you have your x and y value and you have your minimum or maximum point ID, you can draw your graph using pencil to label x, y. And then you have to label your quadratic equation as well. Y equal to 1 minus x squared. Okay, and then you may now label your number on the axis. Okay, since my graph paper is very small and I don't want to go until the value of y equal to negative 15, so my graph going to have the value begin from x equal to negative 3 until 3. Okay, I will have this range. Total I will have 1, 2, 3, 4, 5, 6, 7 plot. Okay, now you may begin to plot your graph. When your x is negative 3, this is x, right? Over here is x, negative 3, and your y is negative 8. Since the question asks you to find the lines of symmetry and coordinates for minimum and maximum point, so your lines of symmetry means that a line that going to cut your graph into equally half, identical half. So you are going to cut from your maximum point here. Okay, when you cut from this point, when your x equal to 0, your graph going to cut into identical two image, right? You cannot cut here, right? It will be unequal. You cannot cut here as well. You don't even cut here, right? That's why this is our lines of symmetry, a line that's going to cut your graph into equally half. So lines of symmetry equal to x equal to 0 over here. Okay, and then over here we say that we have a maximum point. So the maximum point, you give the coordinates. We will have 0, 1. So this will be your answer for lines of symmetry at maximum point. Now let's look at question 8. When you have your quadratic equation y equal to 3x minus 2x squared. Over here is negative 2x squared, right? Means that your graph is going to look like this lah, open downward. Okay, but they do provide you with the range of x must be between negative 2, equal to negative 2 or greater than negative 2, but smaller or equal to 3. So you must know that your x value will be between negative 2 until 3. Okay, substitute all this value into your equation, you will get your y equal to all this number. Okay, but as you can see, the value here is not in pair. The y value is not in pair. What does it mean? As you can see from question 3, we have negative 15 with negative 15, right? Negative 8 with negative 8, negative 3 with negative 3, 0 and 0, and we have one maximum point. But from here, we don't even have a pair of the y value. It's all different. What we're going to do now is we have to add more column in between this number. I'm going to try to add every half of the value. Okay, what does it mean? Initially we have negative 2, right? And now we go with additional 0.5, which is negative 1 and 1 over 2. Negative 1 remain. Okay, I actually added a few columns, as you can see. 1, 2, 3, 4, 5. 5 column over here for your x value. And now you may copy the previous y value that you found here. Okay, y equal to negative 14 when your x is negative 2. Okay, just extract your y value from your previous table. Okay, and now we're going to identify the missing column here. Okay, what is your y value when your x is equal to negative 1 and 1 over 2, which means negative 3 over 2 lah. We put it into improper fractions. Okay, so you will get negative 9 over 2. Over here as well, it's negative 3 over 2. Minus 2, you will have 9 over 4. Okay. Okay, since the denominators are different, so I'm going to divide by 2. I will get negative 9 over 2 minus 9 over 2. Okay, which is equivalent to negative 18 over 2. And you can put it into whole fraction, which is negative 9. Substitute your y value, fill up your table of your y value with negative 9. So when your x value is negative 1 and 1 over 2, your y will be negative 9. We try to draw the graph first, then you will see the reason why we have to ensure there's one minimum or maximum point here. based on previous question, we have one maximum point here. After 0 and 0, there's one unique maximum point. But over here, after 1 and 1, there's no minimum or maximum point. Okay, so this is your graph paper. Ensure that you have your labeling x and y and all the numbers on the x and y axis, and as well as your quadratic equation. And now you may plot your coordinates. That is your graph, but as you can see, there's no minimum or maximum point. Over here, it will be a maximum point. Okay, it is a downward open parabola, but there's no maximum point for this graph. Means that we are missing one y value over here. Okay, remember, we must have every pair of our y value, but there will be one solo coordinate, or we call it the maximum or minimum point. As you can see from this question, we have 0, 1. And then the rest are in pair, but over here we don't have. Means that there will be one value in between here. Okay, how are we going to identify? Okay, we add another column here. So in between 1 over 2 and 1, what is the value? If let's say you cannot understand, if let's say we have 1, right? Over here we have 1 over 2. So what is this number going to be? It have to be even number lah. It have to be equally half lah. So imagine if you have 4 over 4 as your 1 and 2 over 4. So in between we have 3 over 4. You guys get it? Okay, so we have to identify when our y there is 3 over 4. What is the y value? Okay, substitute back to your equation. You have y equal to 3x minus 2x squared. Okay, y equal to 3 bracket minus 2 bracket square. 3 over 4, 3 over 4. You will get y equal to 9 over 4 minus 2 bracket 9 over 16. Continue to solve your fraction. Make it the same denominator. Over 16. You can simplify your fraction by dividing 2. Okay, and put it back to your proper fraction. You get 1 and 1 over 8. Okay, that is your y value when your x is 3 over 4. And now we're going to plot this one. Approximately it will be here. Okay, and now you may connect your graph using your pencil. Okay, if the question happened to ask you what is the lines of symmetry and also minimum and maximum point, so your lines of symmetry is going to be x equal to this line, where we have our x value at the maximum point 3 over 4, and your maximum point here will be 3 over 4 and 1 over 8. That's how you answer these two questions.